And the recording has started, so we're all aware now. Okay, let me go back to my screen here. All right, so we're going to start out here with the market outages, transmission resources. So again, this knowledge article is talking about the timing, that it's very important that the market is provided with timely updated topology of the EIM's footprint. So this is going to help make sure that the market can do the best optimization. Since it's looking out further, it's going to need that accurate modeling to make sure that the state estimator, the actual flows, that they match, that we have correct congestion pricing and accurate dispatches. So you see there in the first paragraph, it does refer to electrically disconnected. So that other knowledge article is titled Electrically Disconnected Generators. So that knowledge article, we'll hop over there in a moment, but we'll go through this one first, because it is, even though it's talking about generators, it is a factor when it comes to considering your outages. Now, since we just mentioned generators, there is another generator outages knowledge article that has been posted. We are in the process of updating that, so we'll publish a new version here in the next probably couple of weeks for you, and we'll be able to go over that and any of the updates at a future meeting. So we won't really go there into generator outages today, but we will focus on the transmission outages. So here you see that transmission outages, those can directly impact network topology, configuration of it, and the availability of those electrically connected resources. So again, any delays in getting that information sent can have an impact on the market. When outages are put in, there's some information within this knowledge article about the specifications that need to be put in, identity, location of the elements to be maintained, nature of work. So is it out of service? Is it energized work, relay work? Are there path limitations, communication issues, RIMS outage, et cetera? So also those, what is the model system outage boundaries, date and time that it's to begin, as well as what time it's to be completed, and then any emergency return time. So this information needs to be put into these outages so that the market has that accurate information. So, I'm just going to scroll real quick through here to just show you what we're going to be covering, and then I'm going to turn it over to Brian to kind of give a lot more input, the RTMO subject matter expert that's in here. So we also have in this knowledge article some information about the outage management system, and a lot of you are using those third-party software interfaces, and but it's really important that the systems talk to one another, and that the grid operator knows how to not only use theirs, but how, if there's some kind of an issue that they suspect, they can go back into the ISO's version, that they can be validating and troubleshooting any kind of information that they might see. So there are some screenshots in here for OMS about, dashboards. I scroll down a little bit further, an example of a completed OMS outage, and shows the red boxes that show what that information is that needs to be in there. And then a screenshot of showing how the market views highlighted OMS outage data that was input from the screenshot below. Information about what a group identifier is, station, equipment text, start and end date, et cetera. And some other important information that needs to be completed on an OMS card in the switches table. So there's screenshots for that, as well as output dispatch switch element in BAYOP. So you'll see OMS screenshots as well as some of the BAYOP screenshots where you can go and troubleshoot this information. Then there's some additional reasons for transmission outages that are listed in this knowledge article to be aware of, and a few more screenshots. Another BAYOP example used to confirm effective rating changes, and then some market considerations. So again, you know, as soon as the RTPD sees the topology or rating changes, it's going to use those new parameters for the next optimization. So again, that's why it's important to have that information in there so that the market can optimize effectively. So that's kind of the layout of this knowledge article. I'm going to go ahead and go back up to the top, and I'm going to turn it over to Brian to kind of give any kind of input on what's in here, any kind of information. Again, as an RTMO, they see a lot of these issues, so again, he'll take you through this, but also please ask your questions of him and let him know maybe what challenges you're facing with outages so that we can look at any kind of options that we need to make to improve technologies for better situational awareness. Brian?
All right. Good morning, everyone. This is Brian. So this knowledge article is very well laid out for you folks to get a high-level scope of the timing, the requirements associated with transmission outage cards. Before we dive into some of these specific examples, are there any high-level questions that folks have as far as what we've covered so far? No. Okay. Let's start off with maybe we'll go. Do we want to go through the bullet list here? Do we want to just dive into some of these, like page 2, where we start talking with some screenshots?
Let's go ahead and go to the screenshots.
Okay.
So which one do you want me to go to? Or do you want to run it, or?
Yeah, to that first one.
First one? Okay.
So in OMS, just really quickly, hopefully most of you have had some exposure with the OMS system and are using it. I know you guys do use your third-party outage management systems to enter outages, but you can use OMS to view and make sure that the OMS has received the appropriate specifications that you had in the outage setup. This first screenshot just shows how we can search for an outage. This is where you can put in either the participant outage ID or the OMS outage ID. The OMS outage ID would be going in that upper left box, participant outage ID in the upper right box. Once you enter the outage card number into there, then this next screenshot will show kind of a high-level view. It'll show you, the station, the voltage level. It also will show some information about who submitted, whether it was through the API or an individual user. You'll see some of that. You have the start and end times. Just really important that on outages for, say, scheduled work, that those just understand that the market's going to start optimizing based off of that duration of that outage for any equipment that's going to be modeled out. Some common issues that we run into with the EIM operators, and we're going to dive into that a little bit on the electrically disconnected generators. Just from a transmission standpoint, the switches that are modeled open, for example, that are normally closed, those can have an impact not only to electrically connected generators, but also to your ratings on buses, lines, transformer banks, etc. So we want to make sure when you open the card, you can go into the equipment. It's a tab kind of in that second half of the section in the screenshot that you're viewing. There's an equipment tab, and when you click on that, then you can see any equipment that's associated and been modeled into the outage. And the switches that are modeled into the outage will supersede any telemetry. Okay, so if there's SCADA telemetry that actually has a breaker closed, say let's use an example of a low side gem breaker, but the OMS has that switch modeled open. That modeled open outage information will supersede the telemetry. So you might go to your SCADA system, for example, and say, hey, I don't understand why this resource is being electrically disconnected. I show my SCADA as having that breaker closed, but there's probably an outage that's causing that disconnect, either at the low side or maybe at the substation level. So check the equipment, make sure that the switches are modeled correctly. And I know a lot of times it may not be the EIM operator per se that's modeling these outages. I know you guys are often working with your balancing operators and also your transmission operators. So even though they may be submitting those outages, highly recommended that one, we review the switching in the OMS card, and you can also, we'll get to the lower screenshot that shows where you can verify what the market has received in terms of the outage. Yeah, the yellow banner screenshot there, that's a snapshot from your BAOP, and it's in the NA portion of your UI, and you can and it's outage schedules. So this display I use a lot when we have issues come up where a resource is disconnected, or maybe there's congestion on a transmission flow gate, and we're trying to understand what's contributing to that congestion. I will search, I'll do an inline filter for the substation. We can narrow in on outages associated with that substation. And then from there, I can go into OMS and look at the details, look at the modeled equipment out. Sometimes the equipment text is a little bit cryptic. Like, I don't know if you guys can easily see that middle column says equipment text. It's kind of a long string of characters and not real intuitive. Sometimes that's just an ID element name in our model. But in OMS, if we opened up the outage card that's referenced in that group identifier column near the far left, then we can go into OMS and see the exact switches, and they'll make more sense to you. They're your switch names in most cases. Questions on any of those two snapshots or the information we've talked about on those? Okay. Going further on down below that snapshot, Heidi, where we talk about the information that's entered into the outage card with the group identifier, station voltage, and so forth that's listed there. Again, a lot of this information comes right across from your outage management system and enters in for your OMS. Sometimes you folks are having to go into OMS directly if there are any kind of issues, maybe with the API that's carrying that data over. So I know OMS may not be your standard procedure for entering outages, but definitely one that you can utilize to check and also update directly in OMS for any of these specifications. Notice on this screenshot the title of other important information on the completed OMS card is in the switches table. So again, when we highlight that equipment tab in that lower half of the, can you scroll down just a little bit?
Oh, sorry.
Yeah. That switches tab or the equipment tab that's highlighted green on the far left, when we click on that, the equipment, the switches, and the equipment rating changes, those boxes will be populated with any information, any switches that are associated with that outage that have been modeled, either open or closed. So we want to make sure that those are accurate. Again, that's going to impact the power flow, impact your electrically connected resources, and so forth. So very important that we have those switches modeled correctly. And a lot of times when we find issues, it might be a switch or two that were added that maybe shouldn't have, wasn't actually part of the switching order associated with the actual field work. Moving on down to the next section of the KA, this is a screenshot again of your BAOP. Another one that I go to often, and maybe not the EIM operators at the entities as much, but maybe one that we should encourage you guys to visit more often is going into these EIM NA output displays to look at the switch elements for either RTD or RTPD. Again, based on the outage time and the interval that the market's optimizing for, this UI will show any switch elements that are associated with an outage and modeled out. Down below the snapshot, we're talking about additional reasons for transmission outages. If there's a necessity for equipment rating change, and again, rating changes can affect obviously the amount of power flow across the transmission interface. So if we have an equipment rating change in to derate a line, a bank, so forth, you need to ensure that you can verify those within, you can do that within OMS and BAOP using that switch element UI. There's also, I think in the following, there's a snapshot as well that looks at the market flows and line flows for either RTD or PD for any line or transmission or a bank. And that will show the actual market flows along with your ratings, and the ratings can be a normal and emergency rating. So your ERC changes should be reflected in that table as well, assuming that the market interval is looking inside the window of your transmission outage card. So other additional reasons, we talked about ERCs to update for an incorrect rating. Maybe we're pre or post a DB build and the actual rating increases have happened in the field. This is, again, these rating changes will supersede anything that's in the master file parameters or static data tables. We have seasonal rating changes not captured in DB builds. Again, another area where we can use ERC update through an outage card to update those temperature adjusted ratings and so forth. This last paragraph is important when it comes to ERCs and other important topology changes in OMS cards. It's important to remember that the market is forward-looking. We'll key off the planned start date time. We've covered that. If ratings are incorrect or ratings changes haven't taken effect, it may be worthwhile to submit an outage, or if already done, review outage information for correctness. And then that's where we get into the screenshots of, again, back to OMS, where you can look at the setups as far as the elements, the ratings. You can see the substation name and all those corresponding characteristics in the outage card. There's a little pop-up dialog or text that we've entered in here with the two arrows pointing down, saying that after equipment has been selected in the equipment tab, you must add for both the equipment and the rating, and they will then appear below and the ratings can be adjusted. So hopefully you folks are familiar with that within OMS or your internal outage management system, but you can view here to verify that what you expected to be, what you put into your internal outage management system reflects correctly here. Questions at this point? Okay. So we talked about the BAOP UI that we're for market line flows. We'll have Heidi show that here. Again, that's two arrows are pointing to both of the normal rating, the emergency rating, and then you can see what the actual line flows are in the market. Now this is another area that is fairly common in real time. market flows and actual flows that you might be seeing in your SCADA system may be differing. And that could be due to numerous modeling discrepancies, perhaps between our market model and say your state estimator or your SCADA one lines. And again, I think we've had different conversations about transmission conforming to basically match the market model flows with your actual flows that you may be seeing in your SCADA system. So if you folks have questions about that, we can talk about it briefly, but transmission conforming is a tool that's used to basically make the margins nearly the same so the unloaded capacity is viewed correctly in the market. And then this last piece, market considerations. Couple key timing things that we want to be aware of is RTPD often is for the next binding interval, it's about 37.5 minutes out. We need to be aware of the timing of the outages and how the market's looking forward. Like if we have a forced outage event, there are some things that you need to ask yourself, hey, is this forced outage, is it going to undetermined on how long this will remain out, or is it something that might just be out for 0 to 30 minutes? And if so, we can do some things within the transmission conformance, flow gate conformance if you guys are using those, nomogram conformance if you're using those. If it's going to be longer term, something that RTPD where we would need maybe generation commitment changes to redispatch to help manage that transmission outage. Again, looking out 30 minutes or more, or the anticipated return time further out, then we want to get those outage cards in as soon as possible. If it's something that might return sooner, then we can do some things in real time to basically mitigate or work around the short-term duration outage. With topology changes, each time an RTPD runs and RTD runs, it's going to pull in the OMS payload. Okay, so any outage information that's been updated, say like on a forced outage card, that's going to pull in. RTPD will run the power flow, and we'll hand that off to RTD every 15 minutes. If you want the market RTD to see any topology changes sooner, you can request, the EIM entity can request to the RTMO to run a power flow, which will force the market to see those topology changes even sooner. Some considerations need to be made when submitting outages on transmission resources. Start and return times are accurate, and those are things that can be updated if the scheduled time and the actual return time, for example, differ. These are things that you guys are probably already familiar with and doing now, but just ensure that those actual end times, or when an outage returns, that you can update that actual end time correctly. And again, the market will see what's happening in the field sooner than what was the scheduled end time. But the timely manner of that is just all too important for so many reasons. For your setting prices, LMP prices, for your generation, congestion, all those factors can be implicated by the accuracy of the modeling of the outage and the timeliness of the outage that is submitted with the correct start and end times. And we talked about that last bullet with modeling breakers, switches, and disconnects. Again, how important that is for the more accurate our information is into OMS and ultimately into the market, the more accurate the optimization is going to be for market dispatch and for price signals. So we'd like to hear from you guys. We've we've gone through some of these screenshots and the high-level scope of what we're looking for as far as outage modeling, and we're really focused here on the transmission side. We'll dig into maybe the electrically disconnected stuff here for a few moments, but I'd like to hear if any folks on the line have any questions.
Hey, Brian, this is Susie Needlecorn with EIM Energy. My understanding is that we can do the conformance for the transmission resources in BayUp, but I don't recall if we need to do the conformance for the generators are under outages.
When you talk about conformance for generators, are you talking
BayUp.
about? Yeah, are you referring to a generation D rate?
Yeah, that's what I'm talking about. Or any outages we put in the OMS. You know, if a generator auto service, they have the breakers there, the things like that.
Okay. Yeah, there's in the market BayUp, you don't have a generator conformance like you do with transmission.
Yes. Yeah, that's what I recall. Yeah.
So for generation, the way we can mitigate in the near term, in real time, if you say you have a D rate on a generator, the first thing you want to do is update the OMS gen card for that resource and put the D rate in. But we can, if you're wanting to cap the maximum dispatch capability of that resource, then you can do you can put in a manual dispatch that limits the high operating limit.
Yeah, we do that.
Or the low operating limit, or if you want to put in a fixed manual dispatch, keeping the resource at the dispatch signal that it's at currently, you can do any of those three items. So that's kind of how you would manage it for generation. For transmission, you know, if you're managing flow gates, then we can do conforming there, but you don't really have a conforming tool per se like we do with transmission for generation. We need to do that through outage cards and through
manual dispatch.
Manual dispatch.
Thank you.
Sure. Any other questions, comments? Got a quiet group.
I know. Is this thing on? All right. Want to hop over to the electrically disconnected generators?
Yeah, let's do that. So again, we'll expand on electrically disconnected generators in greater detail, but just at a high level, I wanted to bring it up here in the transmission conversation because this is electrically disconnected generators. I would say the most common root cause for electrically disconnected generators is going to be modeled transmission outages. And a lot of times, EIM operators they'll see electrically disconnected come up either in PD or right away in RTD. And in the first market optimization in any one of those market runs that detects electrically disconnected, you'll see kind of like this orange highlight over the resource ID, and then for RTD, there's an electrically disconnected column, just a couple columns to the right of the resource ID with a checkbox. So I often will be, as an RTMO, be looking for all EIM network generators, and I'll sort by electrically disconnected, and obviously there's going to be a lot of anticipated electrically disconnected resources due to scheduled outages. But what I'm looking for a lot of times are resources that are electrically disconnected and that have telemetry non-zero. And in those cases, those are usually, I'll follow up with a phone call to the EIM operator just to make sure that they're aware that we've got a resource that's electrically disconnected, but telemetry and state estimator may actually show generation output. So in a lot of those cases will lead us to a transmission outage that has switches modeled open that prevent the point of delivery of that generation. And that can be, it can be a little bit challenging to quickly identify the outage that may be electrically disconnecting the resource. So those screens that we touched on just a little bit earlier with the NA output displays, looking at lines and switches, what I'll do is I'll go to that display and look for the same station as the generator that's electrically disconnected and look at what outages are associated with that substation, and then I'll go into OMS and look at those switches and see, hey, and then I'll go over to the EMS and say, yeah, the EMS, the SCADA shows these switches as closed, but this outage is modeling them open. And in our EMS, we can actually overlay what the market topology is seeing. So we can see that pretty quickly, and I can relay that information back to the EIM operator. But in many cases, the EIM operator wasn't aware of a transmission outage card that disconnected the resource. So they'll work with their transmission operators and maybe updating the modeling, or they'll check with their field personnel to see what the true status is of that switch. But the key here is just identifying when a generator has been disconnected, and then obviously with the RTMO's help, we can help you discover why. And there are tools that we can utilize in real time to work around this. So if you have, let's just say, a fairly large generator that's electrically disconnected, it's actually, let's just say it's currently out, generating 200 megawatts, but it's disconnected, and now the market's going to try to re-optimize, redispatch generation to make up for that 200 megawatt short. So, like I said, it takes some time. It takes some time to figure out what outages might be causing that, but in the near term, we can do an imbalance bias adjustment to basically tell the market, hey, you could do a minus 200 megawatts in that case for the imbalance adjustment, so it's not going to redispatch 200 megawatts on false electrically disconnected resource. And that can buy us some time to get to narrow in on the outage that might be causing that. But we just have to remember, on electrically disconnected resources, we do not have any other means to override to tell the market, hey, that's a false electrically disconnected resource. We can't do a manual dispatch, telemetry or state estimator. None of those will supersede a topology change that disconnects that resource, even though it may not be real. Maybe it's just modeled in an outage incorrectly, or an outage that was expected to return earlier that's extended is disconnecting that resource. So I just wanted to kind of highlight a couple of those examples, because those are pretty common, and they can be challenging to rectify, in 5 minutes or less. Sometimes because we've seen cases where it might be a substation, one or two substations away from where the generator point of delivery is, that has some lines modeled open or those types of things. So that's where the timing challenge comes into play, and the RTMO will often leverage the real-time OE to help us identify those.
Any questions before we go on, or? Okay.
Key there is identifying, especially for bigger generators, is just make sure your EIM operators are keeping an eye on the startup shutdown screen, because that will highlight anytime a unit's being shut down. It'll give a reason, a few columns over to the right of the resource ID, and if that reason is electrically disconnected, want to make sure that makes sense to the EIM operator, that they're aware of a transmission outage card that is electrically disconnecting that resource. If it pops up in RTD, again, if in that blue box summary on the RTD dispatch control, you can quickly see your external dot, ink, and deck. So you can see the internal dot, ink, and deck. And if you see a large deviation in there from what you're expecting, that table below in the instruction table, that looking for electrically disconnected resources or sorting that dot minus telemetry column, ascending and descending to find which resources might be deviating and why, or if it's electrically disconnected. Those are two quick areas where we can narrow in on a specific resource that's contributing to what could be an erroneous dispatch.
Hey, Brian, this is Susie. So if we have any resources, disconnected, so this display is going to tell us exactly, what happened for all the resources, such as some, generation resources like breakers open, anything, right?
Yeah. That's a really good point, because that's something that RTMOs are asking for as well, to help enhance our ability to troubleshoot or give us the root cause of a disconnected resource. We want to provide you and the RTMO with for example, maybe when you see an electrically disconnected resource, be able to maybe click on that checkbox for that resource and see what outages have just taken effect, either started or ended, or switches that are modeled open at that substation that generator is connected to help provide us more timely information, so we can go in and relate to those OMS outage cards and maybe verify the switching, the scheduled and end times, those type of things. So I agree with you that what you have now, it's a little bit cumbersome how we have to jump around from the dispatch control screen to the NA output displays or OMS summary within the BAOP. You're hopping around on several different screens to try to narrow in on what's causing that. So we're going to look to enhance that soon.
Where did you get information? I'm just curious.
Where do
you get the information? I mean, how do you know if we have a breaker open? I mean, through the
Yeah, it would be in that. I'll have Heidi scroll to it. It's on the it's in the NA section in BAOP. It'll be EIM, NA, output displays, and then outage.
One line?
Here, we'll get to it. So.
Yeah, I was just wondering if that information comes directly from OMS or from the, the market applications we have, the interfacing with CAISO.
Yeah, it comes from for any modeled switch outages, it's going to come from OMS, but it will populate in that BAOP display called NA outage schedules.
I'm sorry, I lost track.
This would be
Page of the transmission market outages.
Like the long yellow bar. Right here?
up higher.
No.
It's like 2. No, you're on the wrong.
Oh, yeah, we need to be on the other.
Going back to the other.
Back to
Oh, sorry. So I was like, I'm not seeing it. Page. Right here.
Going up, keep going up. Yeah, I think that yellow one that's showing at the bottom there, is that it? Yeah. Can you blow that up a little bit? Can you guys see that? So this one with this BAOP UI, it's the navigation to it is EIM NA outage schedules. So with the electrically disconnected generator, again, there's a column in that table that is station. Or if you happen to know the OMS ID, you can plug that in, but in a lot of cases you don't. You're trying to figure out what OMS may be leading to your electrically disconnected resource. So you probably search by station, and then you can see any switches that are currently modeled open.
Yeah, I'm seeing this screen right now. Yeah, now I know where it is at. I don't ever get to the NA screen.
Yeah,
Thank
exactly. It's not a common one. It's more of a troubleshooting UI in my opinion, but one that could help your operators identify outages at that substation. And then you can get the OMS ID. That group identifier in that second to far left column is the OMS outage ID. So you can take that number and copy and paste it right into the OMS search. And then you can get the details on that outage card.
Thank you, Brian.
You're welcome.
This is Justin from PAC. I would have to say this and searching OMS specifically for the start time has been very helpful. Sometimes the outage isn't in the, it might not be at that substation. And if you know what time the electrical disconnect happens, you could search around that start time. Yeah. And the outages will it'll pop up and you'll be like, that one's related, and that's been able to isolate these issues very quickly. Yeah, that's a great point, Justin. So that start and end date that you can filter for near the right-hand side of that UI, that's exactly right. Because you're right, when they're one or two substations away, then the timing might be more important information to narrow in than trying to figure out what substation. Thank 100%, you. Yes. Yep.
Andy? Todd? I just got permission from our Gen Dev, Lori, and she said go ahead and start the test.
Mo? Hey, Mo, can you mute yourself?
Oh, I'm so sorry.
All right, any other questions or comments?
Any other Jen we need to start up, or?
About, Justin, you're a good one to target, with some examples or experiences with whether it be electrically disconnected resources or even back to our original subject of transmission outages. As far as the switch modeling, the timing, how to look up information. Do you have any helpful hints for maybe those out there that are going through the same issues?
The first thing we usually do here operationally is determine if it's real or if we have a model point in our EMS system out of position. So, we bring up the unit and we determine if it's, being modeled on our system as electrically disconnected. We've found in some cases that a switch might be left out of position during switching, which gets sent to CAISO via ICCP, and the state estimator will pick that up as electrically disconnected. So that's a common occurrence. So that's the first thing we usually go through. Next thing, usually, I'll definitely call up the RTMO if it's not that. And the next thing, one of the things that we don't have visibility of is possibly man-repped elements in the CAISO state estimator or the CAISO model. That's something we don't have visibility of. So I usually ask the RTMO to look at their model and determine if there's anything obviously out of place. Other than that, no, I think what you went through is pretty accurate insofar as our troubleshooting.
Okay. Good, thank you.
I think you made a good point where, like Brian was saying earlier, they want more of maybe a checkbox or something to help bring these elements together, because there are a lot of different screens that you need to troubleshoot. So I think this is a good opportunity for, more of you, if you have ideas, since we have these enhancements opportunities and speaking up, say what would you like as well, because that can help the more voices that are asking for the same kind of fixes, the more opportunities that we have to, more likelihood to get some of these changes made that will make it just a little more clear, quicker to find those pieces of information. So, if there are no other questions right now or comments, we'll go ahead and wrap up today. But again, we've got, do we have a question that was going to be asked?
Yeah,
or?
Sorry.
Okay, go ahead.
This is Tammy from Pacificor. I had a quick question going back to OMS. And I know, like, for, certain natures of work, like out of service, then switch modeling is required. So I was wondering, are like switching devices the only thing that the market takes into account, or what happens if you do something like equipment abnormal and you select the equipment? How does the market interpret that?
I think just probably the way you would expect it. Abnormal would just be, if it's a normally open switch and now we're closing it and those type of things. Again, you're basically just telling from a start time and end time. You're giving switches a status that may differ from your normal state.
So, like, equipment abnormal, it allows you to, so if you were to select something other than a switching device, like a line or a transformer that's normally in service, would it assume that it is now out of service, or does it have to be a switching device?
Lines you can do lines, but I think typically if you're going to take model lines out of service or lines that are typically out of service, model them in service, you're probably going to associate the switches as well, right? The line disconnects or breakers. So I think you have to, for the modeling, it's going to need status information. I don't think just line status alone on any kind of outage card. It's going to require switch elements to be associated with that. Just a line stat, for example, the market's not going to necessarily know. It's going to need to know the associated line switch elements.
Okay, so it's always looking for switches.
Yeah, yes.
Okay, thanks.
Sure.
Hey, Brian, I got another question on OMS. So what if our analyst forgot to put in the outage card, when the unit is out of service? So is the market still able to see this unit is disconnected from the market?
Yeah, if the operator has not put in an outage card for a resource that truly is out of service, so the market thinks it's available, the first thing the EIM operator can do is make the unit unavailable, which is right in that RTD dispatch control screen up near the top of the blue box summary. Just below, there's a couple tables to the right. I think it shows in our snapshot there, Heidi, on the disconnected resource. Yeah, right about, scroll up. See the green shaded area that shows the process run? Just to the right of that, there's a section called unavailable resources, and it's got an arrow next to it, just slightly down, right below that. If you expand on unavailable resources, that will show your whole list of generating resources, and you can pencil edit and checkbox any resource that you want to make that, say, has tripped offline, outage card, it hasn't been created yet. As soon as you checkbox that, the next RTD run will take that resource out of the optimization completely. So it will get a 0 dot.
Thank you.
You're welcome.
Any other questions? All right. Well, first of all, I want to thank Brian for being here today and for all of our subject matter experts for being here. And again, we recorded this, so we'll be turning this into YouTube. We'll send out the link. Please share these knowledge articles with your operators, because I know that sometimes they don't get down to who they need to be going to. They are listed in city, so you can find these in the city application, but I know that that's tough for a lot of people to get to. A lot of the operators actually have access to city. So please be sharing these with the people that need to get them. We are working on a portal that will be available through the market participant portal, and we're just about to roll that out, but we've got some access issues that we're just working through. But you'll be able to see these EIM knowledge articles under that training portal that we're creating. But until then, again, in City, under the Q&A, under the EIM imbalance market or energy imbalance market, you can see all the different knowledge articles that we've created so far. And again, for generator resources, we're going to be updating that one, so we'll let you know when that's available. But you can find a lot of different knowledge articles that are being created at this time here, including this electrically disconnected generators for EIM entities, market outages for transmission resources, as well as generation resources. So again, we'll continue to have these every month. We'll be going through new ones that are published, and we'll keep you posted as far as new knowledge articles that are being delivered and are developed and delivered to you. So, all right, well, thank you all very much, and hope you have a great rest of your day.